Hello, this is John Patinella for Full Sail Online Physics at the Los Angeles Recording School with Chris Lippy as the instructor. Today I will be doing the Plop experiment, which is designed to show objects will continue to move due to inertia. I will be using my desk chair and a set of 5 books that will be stacked on the edge of the chair seat. I will then push the chair forward quickly and then immediately stop the chair. The hypothesis is that the books will continue to move forward when the chair stops and will fall to the floor. Alright, so here we go. Here is the chair behind me with the books stacked. I'm going to push it forward and then suddenly stop it. Let's check out what happens. Here we go. So the hypothesis was correct in that the books did fall to the floor when the chair stops moving. And this is because the books are not actually a part of the chair, so that when the chair stops moving, the books will continue to do so and would continue moving if the air molecules weren't present and gravity wasn't pulling them down to the ground. And these are the two main forces acting on the books as they fall to the ground. Now, a great way to bridge this experiment to our recording education is to delve into inertia as it relates to music using oscillators. So if you increase mass, it increases inertia, which is just the reluctance to accelerate or decelerate of the object. With an increase in inertia, the time period of the oscillation will increase also. So the more mass, the more inertia. The more inertia, the longer the time period, and the longer the time period, the lower the frequency of oscillations. This is especially important for mixing audio because the lower frequencies carry a great deal of energy, and because we can't identify frequencies lower than 20 Hertz, they take up most of the energy in the master fader and can add to clipping because of a lack of filtering out of those frequencies. And the sine waves produced by the oscillator are described as oscillating with simple harmonic motion. An oscillation follows simple harmonic motion if it fulfills 2 rules. The first is that acceleration is always in the opposite direction to the displacement from the equilibrium position. And the second one is that acceleration is proportional to the displacement from the equilibrium position. Acceleration is given by the equation it is equal to negative w squared times x, where w is the angular frequency of oscillation and is 2 pi over t, where t is the period of oscillation. So by using Newton's second law of F equals ma and Hooke's law of F equals negative kx, and recognizing that these two forces are always in balance, resonant frequency can be determined. And this is really useful to us so that we don't let the oscillation or oscillator get out of control and turn into an extremely low frequency feedback loop that could blow out the speakers, hurt our ears. So damping becomes really important when using oscillators to make sure the energy does not keep redoubling. And for a lot of oscillators, the damping forces are roughly proportional to velocity. So this leads to an exponential decay of amplitude over time, thereby helping to ensure runaway feedback loops do not occur. So to sum it up, the conclusions from this simple Plop experiment designed to show that the books will continue to move and fall forward due to inertia can also be useful for recording geeks like us to help unwanted sound and energy away from distorting our mix, and that's really what we're after. So hope everybody learned something, and I had a fun time doing it. Talk to you guys later.